Hello everyone, welcome to Lesson 6 of the Crowpanel ESP32 ePaper HMI Display Tutorial Series. In this lesson, I will lead everyone to complete the display of a calendar desktop. The final effect that this tutorial will achieve is like the calendar desktop shown in the picture, which requires waiting for the ESP32 motherboard to connect to Wi-Fi and synchronize to the NTP server in order to display the time. The steps may seem complicated, but the operation is actually very simple. Next, I will take you to unravel the mystery. In this tutorial, there are 6 types of motherboards in this series mentioned in the previous lesson. Taking the 5.79 size as an example, we will introduce the use of related functions. The implementation steps of other sizes of motherboards are similar to the case steps in each lesson. You can refer to the video for operation. If you have any questions after careful study, please contact us. In this course, we will still use the 5.79-inch motherboard as an example to introduce how to operate the dynamic refresh calendar desktop process. Please open the code we provide. Click on the link below the video to download it. Open ESP32 S3 ink screen information. Open 5.79's 32 S3. Select sample command. Open 5.79 refresh time and use Arduino IDE to open this INO file. Next, I will introduce the important parts of the code from scratch for your convenience in making changes when using it. As for the above definition, we will apply it in the code before introducing it. Firstly, please see the setup function. First, connect to Wi-Fi. If the connection is successful, the IP address will be displayed. For the Wi-Fi name and password, you can connect to the Wi-Fi currently used at home or at work. Next, we will call the EPD show picture function to display the temperature and humidity icons. This function has been used many times, so we will not explain its usage here. If you forget how to use it, you can review the second lesson. For AMP server, we use NTP to connect to the network and obtain the time. In the code, we use the pool.nt.org server. If you encounter connection failure during use, you can try changing the server. Config time represents the time zone you are in, and you can search for your own time zone. The code shows setting the device's time zone to UTC+8, GMT+8, disabling daylight saving time, and configuring the device to retrieve time information from the NTP server specified by NTP server to synchronize system time. After synchronizing the time, let's learn how to obtain the local temperature and humidity. Before entering the JS analysis function, everyone needs to open their browser and search for this website. After entering, if you do not have an account, you can click on the Sign In button in the upper right corner to register, fill in the relevant information according to your own ideas, check all, and create an account. Slide the mouse over the username in the upper right corner. Select My API key, copy your key, and paste it into Open Weather MapAPI in the code. After completing this, open this website again. Download City. List, JSON. GIS, unzip it after downloading, and choose the appropriate software to open it. I opened it using Visual Studio Code. Press and hold the keyboard to search for your city. For example, my city is Shenzhen. Get the city number and code. Copy and paste them into the code for replacement. After completing the preparation work, let's enter the JS analysis function. The meaning represented in the code is to enter the server path after connecting to Wi-Fi and obtain local weather data from the cloud. For the city, country code, and Open Weather MapAPI in this path. These are the data we just extracted, so extracting these data is to serve this moment. After obtaining the local weather data, the next step is to extract the temperature, humidity, and location of the city and save them in these 3 variables. After extracting them, it is necessary to display them on the screen. How should I operate? Everyone, please see the Update Display function. Previously, we synchronized the time through the NTP server. Now, we obtain the current time through local time and save the obtained year, month, day, hour, minute, and second in the time info structure. Then, we choose to use them one by one, saving the year, month, and day in the buff1 array, the hour and minute in the buff2 array, and the week in the days of week array. We call the EPD showString function separately to display them, and then use the EPD showString function to display the temperature and humidity we extracted earlier. This way, we can see the results on the screen. Then put the GA's analysis function and the update display function in a loop. For the GA's analysis function, the temperature and humidity are obtained every 30 minutes, while the updating display function updates the time every minute. This way, we can see that the time and temperature humidity on the screen are constantly refreshing. Set up the running environment. If you forget how to configure it, you can review the first lesson. Compile and download the program. Wait a moment, and you will see the refresh of time and temperature and humidity on the screen. For other sizes, the final result is shown below for reference. When you burn the code, the time will automatically update, and the temperature and humidity will also be updated every 30 minutes. Of course, all of our products in this series can be powered by external batteries, provided that the code is burned in. That's all for now. If this class has been helpful to you, we hope you can give us feedback and encouragement. Thank you for watching. See you in the next episode.